All right, in this session, I'm going to talk about what's really our main motivation in this class for covering mobile, and that's the use case of the hybrid app. So this talk is going to be part conceptual, part motivational, if you will, and part technical. I mean, there will be some code snippets in here, not full-blown examples. There's some sample code out there for that, and I'll share with you some interactive sessions on working through those code bases. But for now, I just want to go through kind of the motivation of web on mobile as an extension of our client side driven down into the mobile device, and talk a little bit about the way it's done, at least on Android, and then we'll go to code examples. So, web on mobile. Maybe I've already invested a significant amount in creating my web presence, and I've got a mobile browser now, and I'm not speaking WAP or anything else, and now my computational and rendering power is better on these mobile devices, and my data plans are faster. So, instead of taking my web app and trying to worry about how to put it in mobile, why don't we just take it and point our mobile browser? I got Chrome on my Android phone, or you got Safari on your iPhone. You get Firefox, you get anything you want. You get Opera. I mean, why not just point my browser at a responsive HTML5 application? And in this sense, responsive here does mean responsive web design, which was optional out in the class, I know. But in that sense, responsive here means using the presentation logic of CSS and the capabilities of reasoning about the form factor of your display and its capabilities, so for on the fly, if you will, separating out that presentation logic and our separation of concerns, and handling it so that that HTML5 JavaScript application can show up responsively, if you will, alternate rendering of menus and content and sizing and so forth and scaling to my mobile device. Well, the answer is, well, sure you can. All right, you can if you just have a self-contained HTML5 web application, server-side or server-driven or client-driven. You can certainly point your browser at it. But there's a few factors you might want to consider. First is, what if it is a single-page application? What if it is a self-contained local app? Everything you're doing, I mean, you're basically thinking of it as an app first, not as a website. And you just happen to be using HTML5 JavaScript technologies like you can do in a browser today. That self-contained local app may need to use capabilities on the device. It may need to work, most importantly, in a disconnected mode. All right, and we didn't talk about all the things about working in a disconnected mode like the app cache and so forth. But what if that's part of my use case? What if I simply know that that app needs to work well in poor connectivity areas or intermittent connectivity? Right, you're out driving the interstate. You're driving out a state route. You're going camping. The signal goes in and out. It goes down, up and down between 2G and 4G. You're losing connections as you switch between remote towers and these kinds of things. But I still want a consistent experience while doing that, like it's the app is self-contained and local. Or what if my app has web content and HTML5 content and the like, but is doing those things alongside other activities? And I do mean activity here in the sense of what we talk about, what I talked about in the previous lecture about native activities. What if that's what I'm trying to do? The point here is I want to provide a seamless connected user experience. Now you might say, well, we already talked about in activities where I can render content and pop up my browser and go back with the back button. And yes, you can do that in some use cases. It's appropriate to do that. But you may want to provide a more consistent, themed, embedded user experience. You may not want the user to know what they're viewing is actually HTML5 JavaScript, and that you're switching between native and web view without any well, you just don't want the user to know. You want that to be transparent, right? You want to provide that consistent experience. So some of those are some motivations, some technical reasons, as opposed to just business and user interface reasons. HTML5 is a true cross-platform solution. So again, organizations got to consider, how do I get my message out? I've already invested in web technologies. I just put a whole bunch of stuff in this new HTML5 thing. Do I really want to have to go write a new Java-based Android app, a new iOS-based Swift or iOS app, or do I just want to write one app and run it everywhere, if you will? So, the old school cross-platform days is where you're trying to manage these multiple code bases in different languages and provide parallel features and provide your best approximation, which is basically where you're going to be at with the native platform. Second is a lot of what we do with our mobile devices on these platforms is content driven, right? You're consuming the weather, you're consuming the news, you're consuming social media. They're not heavily interactive. So HTML5 is already an excellent platform and a publishing standard, if you will, for content-driven apps. So why don't I just leverage what the web already gives me as its original killer app as a document-serving platform, because I'm consuming that content anyway. One can make an argument for gaming too. There's plenty of HTML5 JavaScript games, but compared to the native case, the high rendering, high graphic intensive applications, yeah, you're probably still better off native, if you will. You still also have reasons for not using HTML5 and JavaScript. I'll talk about more of those, but some of those are the sensor-driven case, right? All the sensors that exist in your phone, interfacing with them. There are more extensions in HTML5 to do those kinds of situations, but one can argue just the nature of the runtime is better if you're doing any kind of real-time processing of a sensor on a phone, or quasi real-time processing, and you need that tight control loop, if you will. Non-technical, again, from a software engineering perspective, the right ones run everywhere is more manageable for your development organization. Think about, in fact, I got on the next slide. Think about I'm talking about down here at the bottom. Think about the burden on your developers and your processes and your tool chains. If you're adding additional technology dependencies, you're adding risk. What that means is if you do a hybrid application, if you do this case where you're using a web view activity alongside native activities, and you do both, you have this problem of, well, now you got to know a whole tool chain and build process, right? You do an Android Studio with Gradle, but then you're doing stuff with your web technology stack to build and package that and get things in the right place. And then you're doing it in iOS over through Xcode and its built-in tool chain. And, all these things mean additional burden for the kinds of developers you need to hire and the skills they have to have and train. Burdens on your processes and burdens, again, on what I just mentioned, were the tool chains. So all these things can be a reason why perhaps you don't want to do hybrid applications, and you want to stick with one particular platform and just write once and run everywhere. The hybrid case, again, is across development, cross-platform development for the mobile platform. So if we look at this use case of taking HTML5 and JavaScript and the things that come with it, and the CSS as well, and look at doing cross-platform development in it, are there other options? Well, again, one option is just to do all native and manage the things across platforms. And there's plenty of organizations that do that. In fact, most organizations still kind of do that. They just do it in Android and iOS, and they maintain the complexity that goes along with that. A number of folks look at these toolkits. So you may have heard of some of these toolkits. Xamarin, an example is Titanium, another is PhoneGap, or what's now Apache Cordova. And I say mixed results. Some folks swear by them and say the best things. I mean, I've heard mixed results on Xamarin, but I've heard its later incarnations are much better, much tighter. PhoneGap Cordova are originally extremely popular, especially for the cross-platform case of accessing different sensors, because that's very device dependent. And so providing a cross-platform interface to the range of sensors available on your devices. They went through a major refactoring and repackaging in their second one, and kind of like Angular, anytime you do that, there's some folks who have to change your entire tool chain. I think they lost some people, but I still hear Cordova talked about a lot out there. Titanium is still out there. I don't know that I hear as much about it as I used to. Kind of this cross-compilation platform to cross-compile to native code from really JavaScript down to native code. And again, anytime you do cross-compilation, you can wind up with particular issues like that, right? So, smaller but growing number looking at HTML5 JavaScript stack as a core technology developed their mobile apps, and getting away from the toolkits or the parallel development. But what are some of the issues? What are the quality criteria that we need to look at? First is performance. And again, performance here we mean responsiveness to the user, interaction responsiveness. Is it reading from the sensor fast enough? Is it responding to taps fast enough? Is it is essentially a nice interactive application. You do find with HTML5 JavaScript applications, particularly on lower end phones, that some of the size of client-driven web pages, it takes a long time to parse. The parsing, DOM creation, and rendering cycle we talk about introduces lags and delays that are sometimes intolerable. CSS painting can take a longer amount of time, and responsiveness to some of the overlays done in the CSS to a mobile device, meaning when you press on a button, there seems to be a latency there. These kinds of issues do happen. And again, because in HTML JavaScript, right, things are running inside of an environment, essentially a virtual machine. They have to run through the JavaScript engine and that whole rendering process we're talking about. So it's not directly native, if you will. So something that is native is going to be more responsive. Another issue with performance, if you're looking at some of the toolkits, and again, if they're doing cross-compilation in native code, you're relying on the cross-compiler to generate the best optimized code possible, and it's debatable how well cross-compilers do compared to human optimization, meaning a person's writing native code and knows all the optimization tricks in the native core language. Is the cross-compiler going to do a better job than that? And again, especially early on with a lot of these with toolkits, anytime some kind of cross-platform toolkit comes out in any platform, I always wonder about version 1 of it and how optimized the cross compiler is. Same thing happens with object relational mapping toolkits and the SQL they generate for relational databases. User experience quality, so the quality of the user experience. Again, we have a lot of good rendering technologies we understand with HTML JavaScript, but one reason you may not want to do user experience quality is jeopardizing HTML5 JavaScript is because you are rendering inside a web view, meaning basically a web browser, and so you're not doing the native widgets, and you're relying on the browser to use native widgets, or you're relying on the CSS mapping to make it appear like a native application. And sometimes you can have inconsistent user interaction, stylistic, and theming things going on in your user experience when you embed some stuff in a hybrid application, and some of the stuff is in the web view. Also, but that's all. I should also mention it's also an issue for native developers because they go between, I say Android and iOS, and I know there's other platforms out there, but in terms of dominant market share, there's those two plus a little bit of Windows going on. So when we talk about user experience quality, we talk about the user experience standards that exist from those different vendors. Apple has had their UI design approach, and I've forgotten. I always seem to forget what Apple terms theirs. Mechanical design or industrial design, I think it is. Android, Google just put out Google Material Design in the past, I think, year, a set of guidelines, and not all apps conform to it. Apple is certainly far more controlling about the appearance of applications as an extension of the brand than Google is, but they do suggest material design is the best practice now. And then Windows is actually for the longest time out of all of them, going back to their Windows platform, has had specific style guidelines for applications written for the Windows platform that it suggests that developers follow. So that consistency is a big part of what I'm talking about with user experience quality as well. And then our software engineering concerns, the cost to develop versus the cost to maintain. It may not be, develop, and the reason why I separate those out is the cost model is related but can be distinct. It may be faster for you to develop it in HTML5 JavaScript, but maybe the maintenance costs are high because you don't know how fast browsers are going to keep up. Browsers on mobile platforms will keep up with HTML5 standards and implement in particular some of the new features in HTML5. I talked a little bit beginning of the semester with the HTML5 part about how there's some new features coming out geared for mobile devices, tap events, swipe events, right? These aren't the kind of events that were typically there, and now those are starting to gain some traction on the HTML5 platform because they realize you're going to be doing this stuff on a mobile device, and so there's these different kinds of events. Cost to develop is same thing for Android and iOS. They're so different in the languages and tool chains that you're essentially paying to develop an app twice, and then how tied are you to the evolution of those platforms when you go native, right? Android gets revved frequently with its API levels. Android Studio gets revved frequently. Xcode and iOS, they get revved as well. At least it's a bit, one benefit of having a far more controlled process is it's a bit more orderly, if you will. But you're going to be dealing with that catch up as part of a cost of maintenance all the time. So you have to consider these things when you're making your technology toolkit choice. It really shouldn't just be, well, we feel like doing this or this is what I know. Your organization should have understood the types of applications it needs to develop, its core competencies, and its vision for moving forward to make a strategic decision about which one of these approaches, native, toolkit, or HTML5 JavaScript, it chooses. Amazingly, or not surprisingly, a number of organizations kind of fell into what they're doing as opposed to making a real strategic decision. Okay, enough on that. Hybrid applications attempt to get the best of both worlds. So the business case for doing this one is we're trying to get the best, economy of scale, get the best of both worlds, leverage things that we know how to do in the web space, leverage cross-platform, and hope that our performance is good enough by perhaps hedging with the hybrid for native APIs for things that are very device specific. Like your launcher, like your notifications, like interaction with your sensors or whatnot. Can we get better user experience, portability, maintainability through embedded responsive web design? We can, particularly for hypermedia content consumption. I mean, when you're doing pure content consumption, that's a use case I have a hard time getting away from the HTML5 platform from. Other ones, it really depends specifically on both your technical and business requirements in that particular domain. I mentioned things like gaming before, or other things that are going to be highly interactive, perhaps specialized security requirements or whatnot. There's always your specific requirements to consider. But for this kind of class of content consumption kind of stuff, there's so many existing there's such an existing understanding and it's such an existing investment in content generated for the HTML platform that it's hard to get away from it and start going to something else. Not that people won't, but it's hard to get away from it. I already talked about how the technologies can be a challenge as opposed to a pro like this suggests up top. I mentioned the developers' processes and tool chains a couple times now. The additional technology dependencies create more risk because there's more things that will change on you. You may lose a core developer with a key capability, a rev of an API, a rev of a tool change. All these things are going to be disruptive to your development organization. At a lower level, you have to consider how do you communicate in and out of a web view. The web view being that browser you're writing to that's embedded in your application, but now you've got to provide a seamless experience and go from the native into the web view, a native activity to the web view, back out to a native activity perhaps, and pass information seamlessly between them. So I want to spend some time kind of giving an overall set of steps to consider. I don't want you to consider these steps overly rigid like our template and strategy pattern from before, but there are a number of things that you have to address in your code and decide in your code. And so I'm going to include it with some snippets. Realize that some of this code's taken out of context, so you got to look at some full-blown examples. So I have some references to sample apps that I'm going to put out there. And as I said, maybe we'll record some live sessions going through that code. So realize that you're not seeing a full-blown code of application. You're seeing snippets, and I'll do my best to explain the context around them. All right, so apps with web views. So the hello world, the first thing you need to do is actually create the web view. So you've seen a line of code like this before. This presumes that you've created the web view and it's available in your resources.xml that we talked about, meaning there is a web view widget that's already been, resources are in your layout. I mean, it's been identified and remember that XML file is cross-compiled to a file called r.java. In Android, you're not going to see r.java in Android Studio. It hides it from you. You can go out to your file system and find it under the generated folder. But effectively, we have an inherited method on our activity to go find a view by a resource ID. Basically, you're finding this thing in that XML file, and you're getting the object representation of it. So you have to cast it to the proper type, which is a type of web view. And then we can ask for a string. This string would be a URL. All right. And I'm getting that string from the resources strings file. This actually will map to the file strings.xml. Android uses a variant of what's called the flyweight pattern. I'm always talking about the Gang of Four design patterns. Look in there, there's something called the flyweight pattern. They basically, even for string labels on your device, they ask that you declare it externally in strings.xml so it can optimize and reuse the internal storage, as opposed to you just in the code newing up a string. You actually can do that in Java, but you'll typically get barked at as a warning by the compiler saying you don't really want to do that. You want to put it over in strings.xml and expose it as a resource, because Android can use them more efficiently through the flyweight pattern. So presuming you follow that best practice, you get the URL resource, you get it as type string, and you are asking the browser to load that URL. That URL could be a local one, a file colon whack 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 to the assets. We'll talk about that. Or it could be one that you get remotely via an HTTP or HTTPS, although you kind of have to set a flag to enable HTTPS. All right, but step one is you got to create that web view and start setting these things up. The second one, which isn't always necessary. I don't think I did it in the prior example, but typically you're going to want to set up a WebView client to handle URLs. What's the distinction of WebView and a WebView client? Remember, I talked about this notion of an intent before in Android, right? And so there was a slide that basically said, okay, here's some activity where we're doing something, and it wants to express future work as an intent to do something else, and if that intent knows what the other activity will be in the future. All right, so again, use case was a mapping application, and it knows it has a built-in map maybe in its own app. Maybe these activities are part of the same app. They're two components of the same app. Right? It can express an event, name its own class, and say, okay, here's how you're going to handle this request for future work when it happens in response to a GUI event, in response to a timer, in response to a broadcast receiver, whatever. Remember, that's what an event is. It's that abstraction around a request for future work. So in any event, I may have this. This was called an explicit intent. Well, I'm writing it on the activity. Actually, this intent's explicit intent, because I knew the target class, right? I knew this binding. It's tightly coupled. When I had a different case, right? When I had the case of an activity, and it says, oh, I want to go create an intent to use a map. And you may have more than one mapping application out there. Basically, that intent, if it's an implicit intent, looks or requests of Android, what do you have? What map apps do you have and I should bind to? And then Android had registered to it another application, I'll call this the app context, which had some activity in there, exposed via its Android manifest file, which we talked about, that says basically I can handle map intents. I can handle mapping activities, so you can bring me up. So basically this guy registered, if you will, through the use of this Android manifest file, and later this thing said, oh, I need a map, let me go ask Android, and it said, oh, I got one of those, somebody's registered that to me. Okay, and so that's how it gets bound, and that this activity winds up through that intent bringing up that activity. Okay, again, reminder of a background. That's stuff we already went over. The reason why I bring that over in the context of a web client or web view client, the web view client, I mean, realize what happens when you go to load URL like this, and you saw this when I did the sample app. Now I remember. When we go to load URL like this, that load URL is basically going to ask Android, what do you want to use, right? What do you want to use? And by default, Android's going to go back to its, in a sense, system registry, right? It's going to go back to this guy and say, oh, somebody's already registered with me. It's that guy. But you might be sitting here saying, well, I really just wanted to use my own web view in here to do it. I didn't want to go out to the system or anything else. If that's the case, then you basically what you have to do with this web view is create a client of it, bound to it, that says, that is wrapped inside here that says, okay, I'll handle my own URLs through my own WebView, through my own WebView client, and I'll only go out this direction for things that don't match the URLs I want to match, which means as part of this relationship I'm drawing down here, there is essentially a filter that indicates what URLs I'm going to handle locally, and then all the other URLs will still go out the traditional route. Okay, how does that work? The main thing you would do in a WebView client, you can do a few different things, but the main thing you can do in a WebView client is you're going to override a method called override URL loading. And what you're going to do on here is you're going to basically have the logic to determine whether or not the WebView itself should load the URL in its current WebView, or whether or not it actually should default back to whatever Android wants to do, and in which case normally that would be bringing up the default browser. All right, so you've got to create one of these. This can be a private inner class that extends WebView client. There's actually misspelled there. There's actually a few different WebView clients that you can use with some different behaviors, just so you know. But the default standard one is WebView client, and you can create one of these and bind it to the WebView via the set WebView client method. All right, so kind of an interesting concept. I mean, you can get a WebView to work without setting the WebView client, but realize you won't control what URLs, all right, you react to internally. They could wind up outside your application. Step 3, enable JavaScript. Enable JavaScript, you got to go to the WebView, get its settings, set the settings, set JavaScript enabled. By default, it's not enabled. It's not like a web browser. I mean, it used to be in the old days, JavaScript wouldn't be enabled, neither were cookies. But now most websites use JavaScript and cookies, so these are always turned on by default. You can actually go into your settings and turn them off, although a lot of sites won't function anymore. In a WebView, WebView takes another approach for security reasons and basically says, I'm going to create a very simple WebView with simple functionality, and you need to enable other things that you want to do. So there's actually a whole bunch of stuff on the WebView settings, or the web settings, that you might want to enable. Cookies are another thing. All right, so you should look at that, the things you can turn on and off. But the main thing is, for application behavior, we want to use JavaScript, so we want to set the JavaScript to be enabled, and so these lines of code will do it. After that, we got to decide how we're going to handle page navigation. All right, so page navigation, interesting case. Let's go back and talk about our web activity stack. Right, so we have an activity. We spawn another activity. Right, these go on an activity stack. We spawn another activity. And again, these may come from different apps on the system, or they may all come from the same app, right? Maybe the first one, A1, came from my blue app, but then my next two came from my green app, and then the next one's A4 and A5 come from my red app. Okay, but at any point in time, again, Android is maintaining the stack. The current thing that's rendered on the screen is the top of the stack, A5. Well, what if A5 is a WebView, right? If I go and look inside this WebView now, I'm going to load an initial URL, which means, my load URL is going to load something. That something is going to be some kind of content, and we'll just call it a page. We're loading a web page of some kind, via a string, via a local URL, via a remote URL, whatever. We have a web view with some content in it. But now maybe we have some navigation. Maybe that web page has some links, and we handle them through our web view client. And I have a second page. So this is P1 up here, and then I navigate to P2, and then I navigate to P3, and so forth. Well, I'm used to, in a web browser, using a back button, right? So I'm used to being able to say, oh, let me go back to P2, and then I'll navigate over to somewhere else, P4, different page, right? That's how the default browser back button behavior works. The problem is we have a polymorphic issue, right? Because on our Android device, we got a little menu bar at the bottom, which has varied based on your different versions. But we basically have some kind of home icon. Used to be a home, now it's a dot. The set of applications currently existing and running, and then we have a back button, right? And this is the only button we have to go back. But what are the point is, what's the semantics of the back button? Is the semantics of the back button the default in a web view, the default behavior of Android, the default behavior being I'm going to pop the activity stack, Right? So if I'm sitting here navigating around these pages and I hit the back button, if I rely on the default behavior, I'm going to pop the activity stack and this whole web view is going to go away and I'm going to wind up in A4, right? But maybe that's not what I want to do. I want to provide a back button so somebody could go back from P3 to P2 so they can navigate over to P4, maybe back up to P1 or whatnot. In other words, I only want to use the back button to go back while I'm in the context of the web view. And then maybe when I go all the way back to P1, the first web page I visited, and I have no further history, all right, browser history within this particularly short-lived web view, then maybe if I hit the back button, I want to go back here. Well, actually, I drew it to the wrong spot. This is A5. So what I really want to do is to pop the activity stack and wind up going back to A4 that way. Meaning I want dual use out of this guy. First I want to go backward through my browsing history as I'm accustomed to in a web browser. Then I want to go ahead and when I'm done and at the root of my history, I want to be able to pop and have it act like the Android back button again. Well, to do that, you actually have to program it to do that. And so to do that, you have to handle the on key down, where the on key down represents the key code back, which is the constant defined on the key event for the Android back button. And you have to ask the web view, can you go back? Meaning, are you at the root of your history or is there any history left? If you can go back, then you got to ask the web view to go. It's got a go back method, right? So this is the browser back button method, if you will. But you got to call it. You're basically intercepting the Android call for this event to Android and saying, I want to go back in the web view and not go back and pop the activity stack, and you return right here. If it isn't, there's no back key or there's no web history, meaning we're back in P1 and we want to navigate backward, then I want to use the default system behavior and just act like a normal back button behavior. And again, that normal back button behavior is to go back to the Android's activity stack. All right, so you got to decide if you want to do that or not. And if you don't have that in there and basically ignore it, then you're going to be stuck with Android's default, and you're going to pop out of your web view on the first hit of your back button. All right, Hybrids app with web views. When you get through those kind of preliminaries, now you want to enable content interaction. So you need that widget. That widget, again, is the web view. It's been around since API level 1. It's evolved significantly, though, over time. Basically, what you have is what's called a Chromeless browser widget, not Chrome as in Google Chrome, but Chromeless, and all the adornments are there. And as I said, or even the default features you're used to in a browser, like JavaScript and cookies, are by default disabled. But basically, this thing defines its API and how it's going to play with other native Android widgets in the hybrid space. But now I want to do hybrid. So the things I have to worry about is how do I communicate information back and forth. All right. If I want to start with this, step 5 starts with the use case of in the JavaScript and I want to call a Java method out on the native side. So I'm in the web view and I want to call something that's out in a native activity. All right. To do that, you have some class that you create, and it doesn't extend anything. It doesn't have an annotation, but you use an annotation on the individual methods that you want to expose to the JavaScript side. And you don't have to expose all the methods. You can be selective. But here we're exposing 2 methods: collect underpants and profit. All right. Step 6, I have to add that interface to the web view. So I'm creating an instance, all right? Here's a call, add JavaScript interface on the web view, all right? So that method exists. Its parameters are an object instance. In this case, I'm calling tweak. The this I'm giving is, by the way, is a context, and that's more important on the native side, but essentially, it's giving a contextual bundled information to fire up the tweak object. But outside of that, not important. I'm not showing you details of anything that's in there. It's just something that you need to do is fine enough for us. And I'm passing in a string identifier. Why? When I go to the JavaScript and I want to invoke those 2 methods that I just created, I have basically what I'm going to do is I'm going to create standard HTML with an on-click event and a show part. This isn't actually right. This should be S message, right? And I want to show you killed Kenny. Then I'm exposing this message this way, standard JavaScript. But now I'm calling these methods via the GNOME handle, and I'm calling the methods that are exposed on the tweak object. So there's a binding here that goes on, and then you're using that reference in here on the JavaScript side. So you don't reference tweak, you use a dot notation on GNOME. All right. The methods in Java are not static, so there was a tweak object created. The point is the tweak object is going to run in a different thread than the one it was constructed. So if you run the new, sorry, and I'm making a mess of this again. If you run this line in your standard main activity, that means it's running on the main UI thread. All right. The tweak object, though, is actually going to run on a different thread than the one it was constructed in, so it doesn't block. All right. And you have to be aware, because you have to be very careful about whether or not, in this code here and here, what you can actually access out on the native side and how it communicates with stateful things out in native activities. All right, because the real problem for Android isn't the cross-language stuff. The real problem is we're on an activity stack, right? Maybe A4 and A5 belong to these, and if you're saying that A5 wants to make a code out to the native side, well, there's already native activities on the stack that you may be messing with its state. All right, and you may be messing with its performance and threads and so forth. And so you have to be very aware of that kind of manipulation you're doing when you get into that kind of code. All right. All right. That approach makes Java callbacks, if you will, available in the JavaScript. What about starting from the native side, the Java side, and passing information into the JavaScript? This has actually evolved quite a bit in Android over time. For example, there used to be a bug in the Honeycomb, the 3.x versions, because you used to be able to do, even in a local asset, you could do, you could say one way to pass information is to simply, whatever your local asset URL is here, is I'll just put a query string on it, right? I can pass information to a URL through a URL by using the query string. Well, they didn't include that in 3.x versions. Also, we also have a problem if we're using local assets like that, meaning we load strings or we load file-based assets. We can't rely on HTTP because we're not using HTTP when we use a file-based URL, meaning you're taking a local package assets that's going to be inside the package APK file and you're accessing it via this local URL. I mean, when you run things in your browser off your laptop, you've probably seen, or you should be looking for this file-based URL. But realize when we do that we don't have access to HTTP, which means we don't have all the request headers. And we've talked about using, right, our steps are to parse request headers and then parse parameters. We don't have request headers, so we don't have anything to parse. We can't do it, right? So these are some of the limitations. One thing that you can do is modify the load URL to actually explicitly call a JavaScript URL. I didn't talk about JavaScript URLs or URIs, but you can actually, sometimes you see them in a web page, you'll see like a :void 0 and stuff. There, you can directly invoke and reference things in the JavaScript scripted side through a URL like this. So you can actually tell the web view to load and execute in this way. But this is considered bad because remember what I was saying about the thread. We have a main thread that's running, and we're going to block that. All right. Instead, again, we're on the Java side and we're doing something in the JavaScript side. So let's say I'm trying to pull information out of the web view. Maybe I have something to access local storage embedded in the web view. Well, if I do that, what I'm saying is that my native side of code will become unresponsive until that completes. Maybe that won't be a big deal, but it could be, so it's considered bad form. What is the new API since I believe KitKat is an evaluate JavaScript call. That that evaluate JavaScript is executed asynchronously. So this is a Java method that has asynchronous behavior. You're used to asynchronous from Node, so you know the pattern, right? Here we can send in whatever our script is, our reference to it, and so forth. I'll show you an example. But now we're going to pass a callback. That callback is going to be invoked on the Java when that JavaScript finishes and we come back out of the JavaScript interpreter. So that value callback has one method on it. It's an onReceive value that's going to receive the return value, whatever's brought back from the execution of that script. All right. I'll show sample code of both directions. I mentioned already there's a JS interface project out there that'll do that. I'm going to give you some more. That will help you with your lab. So you can see both of these things in practice. But again, you're going from native to web view activity to native. You may have to worry about how you communicate from the Java side to the JavaScript side and back. All right, and those are the general approaches, and we'll do more specific examples with the code. Hybrid app summary for the use case where you prefer native for highly interactive, but HTML for content. That's what I think the core use case is. I personally believe I have friends who work more in the mobile space than I have, but and I particularly I know the head of the Phoenix Mobile Users Group, and he's like, no, native, you got to write native. HTML5 is just not good enough. But I've written several in my lab that have been native, and I've written several that are HTML5 based. And I do believe that HTML5 will start to dominate. It'll start invading even the interactive space, and we'll see more and more of pure HTML5 apps, and even the notion of a hybrid app will decline as a result. I certainly could be wrong about that, but I think the performance issues are resolvable as the devices get better and better, and as HTML5 gets better and better, and the JavaScript engines and the CSS engines inside these browsers get better and better, and able to run on these multi-core smartphone platforms now. I think the real drag on that happening is going to be security, not performance. I think performance is already showing it can be performant enough in HTML5, but there are significant security concerns when it comes to using HTML5 that, you're still kind of sandbox. You still have cross-site scripting. I mean, we got to talk about security. But we do have some security concerns, and hackers have long targeted HTML5 already. So by using something that's cross-platform, you're also opening yourself up to some more prevalent and studied common attack patterns that hackers use. Anyway, I think that's going to be the thing that's going to be the drag on the takeover of the world by HTML5, if you will. The mechanisms for achieving data and control integration across the web view have been changing, the buggy and frustrating, particularly as you go from Java to the JavaScript side. But I will say it does seem that it's stabilized some.